All right, hi everyone. Ready for the last session of the day? My name's Adam Ralph. I originally come from the UK, just outside London. These days I live in Switzerland. I've been living in Switzerland for a very long time. And I work for a company called Particular Software. We are the makers of NService Bus. Start of shameless plug. If you're interested in NService Bus, do go and have a look at some really cool monitoring stuff we're doing around monitoring of endpoints. That's the end of the shameless plug. I'm not going to talk much more about Particular Software, apart from one thing. We are a 100% remote working company. So everyone works at home, even the CEO. We do not have an office anywhere. And I decided to take advantage of that and buy one of these, and I spent the whole of the summer traveling around in this thing. This was my office and my home. My girlfriend also works remotely now. If you're more interested in that, I am going to be doing a talk about this called Code on the Road. So look out for that if you're more interested in that at some events later this year. I look after a few NuGet packages. Some of the more interesting ones are Fake It Easy, which is a mocking framework. That supports .NET Standard 1.6. LightGuard is a guard clause library. I'm sure you've all seen and heard of those. So you can write guard against null argument, that kind of thing in your method names. I think it's going to be redundant in C#8 with the nullable reference type thing. So I'll be quite happy to put that to bed. But anyway, for now it supports .NET Standard 1. Xbehave.NET is an XUnit extension for writing tests using natural language. That supports .NET Standard 1.1. And NService Bus RabbitMQ, the current beta, which is RC any day now. And we do run proper RCs. It's not like the .NET Core 1 RC stuff, if any of you remember that. The RC will be the RTM if there are no bugs. That supports .NET Standard 2. So what is this .NET Standard malarkey? But I love speaking in the UK because I can use words like malarkey, and most of you understand what I mean. Sorry if you don't, it just means stuff. So .NET Standard, let's look at the problem it's trying to solve. So in the early days, we had the .NET framework. So you compiled against the .NET framework, you ran against the .NET framework. And Mono was a cross-platform implementation of that, and still is. And that allowed you to run on a Windows server and using Mono, Mac and Linux. Anyone here use Mono much? I see like 2 hands going up. So yeah, it's not something which was used very heavily, and I think realistically your kind of mileage varied a little bit as to how well it worked. But Mono went on to become something else. Then .NET Core came along, and that allows us to run Windows on .NET on things like Windows, Windows Server, Linux, Mac, and Tizen. Does anyone know what Tizen is? Anyone? Yes. Would you like to shout it out?
Yeah, okay. It's a operating system from Samsung. They make it for refrigerators, phones, smartphones.
Correct. It's an operating system by Samsung it's a mobile operating system, but they put it in all kinds of devices like fridges and smartwatches and TVs and that kind of thing. And it's yet another place, it's Linux-based, but it is yet another place where you can actually run .NET Core. And then we've got Xamarin OS and Xamarin Mac. This is what Mono actually spawned. Mono kind of went on to spawn these projects. That allows us to run .NET on iPhone, iPad, and Mac when you want a GUI. Xamarin Android kind of just runs on all kinds of different things these days. So all the things. And UWP, none of the things. No, I'm being mean. No, it does run on a few things. So the point is that gone are the days of just the .NET framework. We want to run, we actually now have the ability to run .NET on all kinds of different platforms via all these new runtimes that are coming out of the woodwork. So when you write a typical .NET app, it's not long before you bring in some kind of NuGet package, right? It's an unusual app that doesn't use some kind of external library and usually these days via a NuGet package. So as a producer of a NuGet package, and obviously as a consumer, you want to be able to use those NuGet packages in potentially any of these platforms. In the early days, people only really built for the .NET framework. These days, people want to be able to use NuGet packages from the gallery in potentially any of these. Now, there was a solution for this previously called portable class libraries. Does anyone know about portable class libraries? Yeah, a few of you have heard of them. So portable class libraries were designed to solve this problem. Unfortunately, it became kind of the portable class library fiasco in the end. That sounds a little bit harsh, but bear with me. So in the beginning, as I said, we had .NET Framework 4. Right? Things are very simple. And then this thing came along, Silverlight 5. Right? What are you smiling about? Silverlight, it's great. You have to support it. Lucky you. I actually misspelt this when I wrote the slide. I wrote Sliverlight 5, but I think that has a kind of ring to it, so I'll call it Sliverlight 5 for today. There's an intersection between the APIs that are available between .NET Framework 4 and Silverlight 5. Right? There is some stuff which is common to them. System object being the most obvious, right, with the same methods and properties. So the idea was, well, why don't we define a thing that you can compile against, which defines the cross-section of these two frameworks? And that was called the Portable Class Library Profile 14. If anyone knows what that 14 means, please let me know. I have no idea. But anyway, it was called Profile 14. It defines the overlap between these two frameworks. Now, this is great because you can now compile against a set of reference assemblies called PCL Profile 14. And then that assembly which you compile, you can pick up and run against either of these two platforms. We can then introduce another platform into the mix, .NET Core 4.5. Anyone remember that? That was a thing. If you're interested in .NET version numbers, come to PubConf tomorrow because Mark Rendell's going to be doing a talk about .NET version numbers, so all will be revealed. But anyway, there was a thing called .NET Core 4.5, and the intersection, or rather, the bit that exists in all of these, all three, became Profile 37. And there is some stuff that only exists in .NET Framework 4 and 5, so I've labeled that there with the Profile 14. And there's some stuff which only exists in the overlap of these two, right? And that's Profile 5 up there. There didn't happen to be a profile released between which covered .NET Core 4.5 and Silverlight 5. I don't know why, but they didn't actually fill in all those gaps. So far, so good. Then we introduce a fourth platform to the mix, which is Windows Phone 8. Now, there is a fundamental problem with this diagram. Can anyone spot it? Can't understand it. That's the main problem with it, yes. And there's one little technical problem, which I'm a little bit embarrassed about because I did maths at university, so I should know this stuff. But there is nowhere for me to put a label for Profile 14 for the intersection with only Silverlight 5 and .NET 4. I can't put it anywhere on that diagram. And it turns out, I'll go back a slide, so it turns out that this is a Venn diagram, right? And a Venn diagram describes, it actually shows all the intersections of all the sets on the diagram. Venn diagrams were described by a British mathematician called John Venn in the 19th century. It turns out that this isn't a Venn diagram. This is actually what's called an Euler diagram, which was described by a Swiss mathematician called Leonhard Euler in the 18th century. And an Euler diagram only shows some of the intersections of all the sets on the diagram. So I Googled for a 4-set Venn diagram, and I found, so that's another example of a Venn diagram, by the way. So I guess most of you here are probably from the UK. So when we kind of describe the layout of the British Isles and Ireland and everything, all we have to do is verbalize this very simple diagram, and we can tell people from elsewhere what it's all about. So it turns out that, so yes, this is not a Venn diagram, this is a Venn diagram, right? This is a 4-set Venn diagram. And applying our profiles back to this, we found a place for Profile 5, we found a place for Profile 14, right? That was the problem, Okay, and we've got this new one in here coming out called Profile 136. Right, so that's 4. Now, if you look at the list of all the PCLs that are available, it goes further than 4. This one has 1, 2, 3, 4, 5. And of course, it's not possible to draw a 5-set Venn diagram. Or so I thought. This is a 5-set Venn diagram. When you want 5 sets, you have to kind of use this weird, I don't know what to call it really, a frankfurter in kind of a wasabi bread roll or something. But that is a 5-set, and you can get silly with this, right? You can go 6-set Venn diagram, you can go 7-set Venn diagram, and in 2011, a bunch of people from the University of Victoria in BC in Canada drew, for the first time ever, an 11-set Venn diagram, right? Getting quite nice now. And applying our profiles to this, I think the problem that you called out, Brian, is really becoming apparent now. We cannot understand this anymore. I made that profile number up. It's as good as any other. So this is why I'm saying portable class library fiasco, right? This does not work anymore. And it's a bit harsh because it was well-intentioned, and given the same problem back then, I may have come up with the same solution myself. But with all these new platforms appearing, it soon became clear that this was not going to scale, because every time you add a new platform, you potentially double the amount of profiles, right? It just spirals out of control. So we needed a new solution for this, and I did pour myself a glass of water before, but it was stolen. And the solution is, of course, .NET Standard. Do you like that logo? I submitted this as a logo, but I got knocked back. But I'll try again. All right, what is .NET Standard? So .NET Standard tries to do this, right? Instead of trying to take the intersection of all these sets and trying to come up with some really kind of complicated scheme, all it does is it looks at the intersection of all of these platforms. So there's a place here where all of these overlap, and there's a whole bunch of APIs which exist in all these platforms. And .NET Standard takes the biggest intersection of those that it possibly can. So for one set of versions of all these platforms, there is just one .NET Standard. You only have to target one thing, .NET Standard. You don't have to choose between profile this and profile that and profile that. It was really difficult to know which profile to choose back then. Do I choose one? Do I choose many? It was really complicated. This makes it much easier. And the way that the versions of .NET Standard itself work like this, so each one is a superset of the one before. So we've got .NET Standard 1 in the middle, we've got .NET Standard 1.1 a little bit bigger, a little bit bigger, a little bit bigger, until we get to .NET Standard 2, which was in fact much bigger than .NET Standard 1.6. A bit more on that in a minute. What this means in terms of platforms is this. So for a given version of .NET Standard, these are the versions of all these platforms that it supports. Oh yeah, this is some really big version number. It's like 10.0.16299. And when I wrote it in, it expanded these columns and made it look horrible, so I just wrote version silly. It's a silly version number. I don't know why it's not just 10.1 or 11 or something. Now, the implication of this is that when you target a given version as compared to targeting another version, let's say 1.0 versus 1.1, if you target 1.0, your library has the biggest set of compatibility with the platform. So you can use your library on all of these platforms, including Windows Phone Silverlight. As you go along towards the right, so if I decide to target .NET 1.1 instead of 1.0, I lose support for Windows Phone Silverlight. Right? I'm sure that's not going to be a problem for too many people. But the way these version numbers is in some way a little bit counterintuitive, because as developers, we like the new shiny. Right? So, .NET Standard 2, I should target that. That's the best. In a way, yes, it gives you a lot of APIs, but the problem is if you target .NET Standard 2, your package can no longer be used on these older versions of the libraries. Now, if you go between .NET Standard 1.1 and 1.2, you kind of start to lose support for these old Windows Phone 8 and Windows Phone Silverlight things. It doesn't really matter too much, right? They're kind of dying if they were really truly alive to start with. But when you go from 1.2 to 1.3, you drop support for .NET 4.5, right? I would hope that most people are on 4.6 these days, but I know it's like working in a big company. We get held back on old frameworks. So moving from .NET Standard 1.2 to 1.3, just, that's an example of where you might suddenly cut out a bunch of users. Now, just because a package targets .NET Standard doesn't mean we can't multi-target anymore, right? So you could choose to support .NET Standard 2 and ship a .NET Framework 4.5 assembly in the same package. So you keep supporting the two in that way. But I spoke to one person, and he told me that when he creates a new library, he first of all targets .NET Standard 1. And tries to write the things he wants to do. When he finds that there's an API he needs which doesn't exist in 1, he goes to 1.1 to see if it exists there, and so forth and so forth. So in many ways, it can be a good idea to always target 1 to start with. Now, there's a kind of sliding window of relevance here, because obviously as time goes by, this older stuff is going to become less and less relevant, But I still think that if you can, just target 1, why not? Because then you can be, your platform, your library can be used everywhere. A little note on .NET Standard 2. So the original intention was for .NET Standard to support Semver in its versioning. What that means is that 2.0, you rev your major version when you make a breaking change. And originally, .NET Standard 2 was going to be a breaking change. Originally, it was going to actually cut out some APIs which were in 1.6 and 1.5. And when this was kind of announced, the community kind of threw its toys out of the pram and complained about this. And a lot of feedback was given and listened to, and the decision was made, no, we'll make it backwards compatible. We'll actually make it a superset in the end. However, so what this means is that .NET Standard 2 only really needed to be called 1.7, according to Semver. But for whatever reason, the 2.0 moniker stayed. Semver doesn't say you can't upgrade the major version when you don't make a breaking change, so I guess that's fine. But .NET Standard 2 is quite a change from 1.6, so I can kind of understand why they wanted this to be a bigger kind of thing with a bigger kind of announcement associated with it. The documentation around this is really, really good. So if you follow URLs like these, by the way, don't bother trying to memorize these now or take photos. I will tweet the link to the slide decks. They are HTML based, so you can just browse them. This is my Twitter handle. If you don't see them, just tweet me and I'll make sure you get them. This is the diff. If you go to these kind of links, you'll see things like this. This is a diff between .NET Standard 1.4 and 1.3. This is actually the smallest diff of all of them. It's really, really small. You can see that all they've done here is added a class, another class here, and a few enum members. And they have this for every single revision. So you can see the diff between every revision. So how does this work? Well, when you build your .NET Standard class library, what you do is you build it against this thing called Net Standard DLL. Right? And this thing is completely empty. Net Standard DLL is totally empty. All it is effectively is a definition of contracts. So I'll show you it here in ILSpy. So it's this one here, Net Standard 2, Net Standard DLL. And if you actually drill into this thing, there's actually nothing in it apart from type and method definitions. So if we look at something like array, for instance, and if you look at the void methods, there's just nothing in them at all, right? It's just empty. It's almost like the concept of an interface. It's just something you compile against when you produce your package. If you look at some of the methods that return objects, they do something slightly stranger. They throw null. Did you know that you could throw null? Right. The constraint of only throwing an exception type is actually a C# thing. It's actually the C# compiler which enforces that. In IL, the CLR will let you throw anything. You can throw null, 0, false, 1, 2, 3. It really doesn't matter. So it's clear that this wasn't written using C#. Right? This must have been written using some kind of like IL generation or something like that. The reason for that is because the CLR will not let you just do nothing in a method which returns something. It either has to return something or it has to throw something. So I guess the cheapest thing you can possibly throw is null. Now it's important to make the distinction between the package and the application. So, and if you like, this is more like compilation time versus runtime. So when you compile the package, so you're not running the package, you're just compiling it. You compile it against net standard DLL. When you use it in an application, things are slightly different. So this is a .NET Framework application up here. So the good old .NET Framework, which we all know for many years now. And that points to the .NET Framework assemblies, for example, MS Core Lib. The .NET Framework application references the .NET Standard Class Library, and that is referencing net standard DLL, as you just saw. However, this is not the net standard DLL that was in the previous diagram. There are many net standard DLLs. The one I just showed you in this diagram, this is the one that ships with .NET Standard itself. This one ships with the .NET Framework. And it uses something called type forwarding. Does anyone know what type forwarding is? No one. Okay, so type forwarding is a mechanism whereby an assembly can effectively pretend to own a type. Think about system object, right? System object is not just system object. System object is actually MS Core Lib system object. That's the type identifier in .NET. A complete type identifier is not just system.object. It's MS Core Lib, and I think it's system.object. That's a complete type identifier. So when the .NET Framework talks about system object, it's talking about MS Core Lib system object. The .NET Standard Class Library is talking about net standard DLL system object. Back here, that system object in net standard DLL is empty. Right? It's got all those empty method definitions and throwing of null. System object in this assembly says type forwarded to system.object in MS Core Lib. So it's a way for type forwarding is a way for an assembly to say to the runtime, I own this type, but when you actually access it, I'm going to forward you and send you over there to this other DLL. That's basically type forwarding in a nutshell. It's existed since, I think since 1.0 of .NET, because it's done quite a lot in the GAC. Question?
Does that have any performance implications?
Does it have a performance impact? So that's a question I very often get asked. I would say the strict answer is probably yes. The practical answer is probably no. This is such a low-level thing that this has been happening probably every single time you've run a .NET application since 1.0, definitely since 1.1. So whether you know it or not, the .NET code that you're running today is doing a hell of a lot of type forwarding already in the background. So it's a kind of thing which is going to be kind of micro pico optimization, that kind of level. Okay, question is it the same thing as you sometimes find in config files? No, it's not. So when you're talking about binding redirects, no, that's for the Fusion binder. That's a mechanism whereby at runtime you can say, when you've got conflicting versions of these assemblies, use this version of the assembly. No, the type forwarding is a lower level thing than that. Does that more or less make sense so far? Yeah? Okay, I see most of you nodding, so that's good. All right. Now, I promised to talk a little bit more about .NET Standard 2.0. This is .NET Standard 2.0 was released last year, and this was a major change, right? Was anyone here at Richard Campbell's talk yesterday about history of .NET? Yeah, a couple of you. So he talked there about how .NET Standard 2 is kind of the first real kind of like industrial strength one, and .NET Core 2, and I do tend to agree with that. .NET Standard 2 was a major change. .NET Standard 1, was all well and good, but there was two main points of feedback from the community. The first was limitations. So limitations is, by limitations I mean there was just not that many APIs available, right? So if you try to actually change your package to target .NET Standard 1 point whatever, as opposed to .NET Framework, you'd soon you come up against this problem of, well, the APIs I need just aren't there. So what they did with .NET Standard 2 was, this is the picture you saw earlier, .NET Standard 1.6 looked a bit more like this, right? It was just a much, much smaller intersection of the various platforms. .NET Standard 2 said, well, let's just expand it. Let's just expand what we are saying should be part of .NET Standard in order for a platform to support .NET Standard. And it moved the picture back to this. So it's actually not too far out of scale, those two circles, because .NET Standard 1.6 had about 13,500 APIs, where an API is a method or a property or an enum or whatever. .NET Standard 2 had around 33,000 APIs put into it. So it's something like a 140% increase, so a massive, massive increase. And what it's effectively done to some extent, it's brought these platforms a bit closer together. Because it's saying that, well, in order to support .NET Standard 2, you need to support this much, much wider set of APIs. So by necessity, the overlap between all the platforms is much, much greater now. And now .NET Standard 2 has probably most of the APIs that are sensible on every single platform. It doesn't have things like the registry, obviously, which doesn't exist on Mac and Linux, it only exists on Windows. But all those APIs which make sense across all the platforms, the idea was to get them all into .NET Standard 2, and I think that's largely been achieved. So that should hopefully take care of the limitations. And I showed you this diagram earlier on. This is the difference between .NET Standard 1.4 and 1.3. If you try and look at the difference between .NET Standard 2 and .NET Standard 1.6, GitHub just blows up and says, sorry, we can't show a diff that big. It really is that enormous. So that largely takes care of the limitations, hopefully. The second thing is this thing that I refer to as paralysis. Taking the example of Fake It Easy. Fake It Easy depends on Castle Core. Taking the example of NService Bus Rabbit, which is the package I look after in my day job, that depends obviously on NService Bus, not too surprisingly. It depends on the Rabbit MQ client. And NService Bus itself depends on AutoFac and, surprise, surprise, Newtonsoft.json. Now, this is a dependency graph, right? Here we've got this is just simple one dependency. This is a two-level dependency graph, right? This one on this one, this one on this one, on this one. So the problem is, if you want to support .NET Standard in your library, your dependencies have to support it, right? Until they support it, you're kind of stuck. So with Fake It Easy, we had to wait about, we were actually we wanted to release Fake It Easy on .NET Standard, but we were we were ready to go, wanted to do the work. We had to wait about 6 months for Castle Core to release a version that supports .NET Standard. So we were kind of stuck for 6 months, right? We were just paralyzed. Now, Newtonsoft.json does support .NET Standard, has done for quite a while now. Maybe that's fixed half the problem, right? So half the NuGet gallery depends on JSON.NET. But the point is, you can imagine much deeper dependency graphs here, right? You can have dependency graphs 4 or 5 levels deep or more. And the community felt itself in this state of paralysis where it just couldn't, we just couldn't move because something down the dependency chain still didn't support .NET Standard. And it was quite frustrating. So with .NET Standard 2, the simple solution was reference anything. Right? We'll take away this restriction. We'll just let you reference anything. Right? Now this is where the real magic comes in. Right? So I'm going to show you this in action because it's a kind of a little bit hard to believe until you actually see it happening. So I have here a solution named .NET Standard Magic, and what I've got here is a .NET Core 2 app and a .NET Standard 2 library. Now what I'm going to do is I'm going to reference from the .NET Standard 2 library, I'm going to install a really old but really good package called Power Collections. Okay, now Power Collections is a .NET frame. I've actually got it open here somewhere. Power Collections is a .NET 2 package. Right, this is not .NET Core 2, this is not .NET Standard 2, this is the old .NET Framework 2, right, from, yeah, there we go, from 2005, right? That's about the time it's released. So this is way before any of this .NET Standard and .NET Core stuff. What I'm going to do now is I'm going to, well, first of all, I'll just use it. I'll just do something using that package. So a couple of using statements. Now I'm going to reference, from the .NET Core app, I'm going to reference the .NET Standard app. And let's just call into it here. A couple more using statements. Oops. Right, and let's run that. And it works. Right, so we've just referenced from a .NET Core application, I've referenced a .NET Standard library, and that .NET Standard library is referencing a .NET Framework DLL. I was pretty amazed when I first saw that. I didn't think this thing was possible. And it becomes really interesting when you look at how this thing actually works. So again, we need to think about the package and the application separately. When you're compiling the package, things look like this. We've got the .NET Standard class library, and that references, as we saw way back in the first example, this .NET Standard DLL, right? This is the empty one. The .NET Standard class library is referencing the .NET Framework class library, right? That's Power Collections in this example. The .NET Framework class library is looking for MS Core lib, which is somewhere in the .NET Framework assemblies. Now, these .NET Framework assemblies here are not the usual .NET Framework assemblies. So these are shipped by .NET Standard. So there is a version of MS Core lib in these assemblies down here, which is type forwarding back to the empty .NET Standard DLL. I'll show you what the assemblies look like. So this is the .NET Standard DLL. Hang on a minute, I'm confusing myself now. Here we are. It's this one here. So this is a version of MS Core lib which is shipped by .NET Standard 2. And this one is type forwarding to, let's just pick that, it's type forwarding back to that empty .NET Standard DLL from .NET Standard. Right? Now, that's the easy bit. If we look at the application, things are a bit more complicated still. The .NET Core application is looking for the .NET Core assemblies. So I think the system object is in an assembly called system.runtime in the context of .NET Core, rather than MS Core lib. So these are just the standard runtime assemblies that are used when you run any .NET Core application. The .NET Standard class library is pointing to Net Standard DLL. This is yet another version of Net Standard DLL. This is Net Standard DLL shipped by the .NET Core platform. And that is type forwarding back to the .NET Core assemblies. The .NET Framework class library is pointing to yet another set of .NET Framework assemblies which are shipped by the .NET Core platform. So there is an MS Core lib in here, in the .NET Core assemblies, which is pointing back to the actual runtime assemblies for .NET Core. Right? So at runtime, everything, this, and this, either directly or via type forwarding, are all pointing back to the runtime .NET Core assemblies. I still have trouble remembering this myself. I have to go back to these diagrams and work through it. But if you think about, yeah, question.
And what happens if the .NET Framework library tries to use a class that is no longer replicated?
Thank you. That's a good question. So the question is, what happens if the .NET Framework library tries to call something in here which actually doesn't exist in here? Right, it's a really good question. It's the first thing that I asked as well when I saw this. You'll get a runtime exception, right? There is just no way around that. It can't do any kind of magic to say, well, I'm actually going to make something happen which doesn't exist in here, right? So, this is a bridge. This is a bridge towards allowing you to use current .NET Framework class libraries which are out there against .NET Standard libraries and in .NET Core applications until those libraries actually support .NET Standard. Right, so in this scenario, testing is quite important. Right? You want to have fairly thorough testing if you're doing this. Right? It's a bit of a hack, ultimately, but it unlocks that paralysis because it means we no longer have to wait for power collections to support .NET Standard. We can just go ahead and do our work now and create a .NET Standard package referencing something like power collections. Question?
Would this also work with the framework applications and the core applications, which the type of one is shipped by the core?
Okay, the question is, does it work with .NET Framework applications as well as with .NET Core applications? The answer is yes, it does. And the reason for that is that where we've got this Net Standard DLL here shipped by .NET Core, we've also got a .NET Standard DLL, a Net Standard DLL shipped by the .NET Framework, which does the same job pointing back to the .NET Framework assemblies. So yes, you could replace .NET Core up here and .NET Core up here and .NET Core up here with .NET Framework, and the diagram looks the same. The reason that this was done was that an analysis was done of the NuGet gallery, and the vast majority of NuGet packages on the gallery which target the .NET Framework actually used APIs which were available in .NET Standard 2. Right, so that's the reason this was done. So in the vast majority of cases, you're actually going to be okay. You won't hit that runtime exception which you mentioned. Now, I thought, just for fun, what would happen if I cut out the middleman, right? So what would happen if I didn't have the .NET Standard library sitting between the app and the .NET Framework library? And this is actually completely irrelevant to this talk, because this is about .NET Standard, but I just wanted to see what would happen. I couldn't resist it. So what I've done here in this .NET Core Magic solution is, all I've got here is just a .NET Core app. Right? Just a .NET Core console app. And I'm going to reference power collections directly. So this is the same power collection as you saw before. And I will just make some kind of call into it. Couple of using statements, right. So this is a .NET Core app installing a .NET Framework package only. Who thinks this is going to work? Not many of you. Oh, you're so pessimistic. I didn't think it was going to work either. But let's give it a try. It works. Right? That was a real wow moment for me. I don't think most people realize this still. You can do this now. You can actually write a .NET Core app and reference a .NET Framework assembly, right? You do not have to wait necessarily for .NET Core and .NET Standard support. Again, test it in case you get those runtime exceptions. But yeah, I think it's pretty amazing. Sorry, I'm not sure I heard you. Is it?
That application was working on non-Windows platform.
Mm-hmm. Right, so if that application ran on a non-Windows platform and tried to touch a registry, actually, Windows or not Windows doesn't make any difference because it's just .NET Core. So if you took that .NET Core app and ran it on Linux, it would explode if the .NET Framework assembly tried to touch a registry. If you ran it on Windows, it would also explode because the .NET Core platform on Windows doesn't have the registry either, right? Because .NET Core is common on every platform. It's not different for Windows. Yeah, so you're going to get that runtime exception. So again, this is a kind of bridge while that library doesn't support either .NET Core or .NET Standard to allow you to get things working. But ideally, you're going to want that package you're installing to support .NET Core or .NET Standard. And really, this just works as simply as that. It's literally just cutting out that middleman there. So we've still got the .NET Core application pointing right through that into the .NET Framework class library, and we've still got the MS Core lib shipped with .NET Core pointing back to the .NET Core runtime assemblies. So things just work. All right, it's a cool bit of magic. It is a hack. Be careful with it, but I think it's pretty cool.
Does that work with lower versions of .NET Core?
Does it work with lower versions of .NET Core? Does it work with lower versions of .NET Core? So like .NET Core 1.1, for instance? The answer is no. Well, as far as I know, I'll be amazed if it does, because this type forwarding magic was part of the whole 2.0 release. Give it a try. If you want to try this yourself, you need .NET Core 2. You need these are the minimum versions of the IDEs you need, and obviously Visual Studio Code is just being released all the time. These are the repos. Again, you'll get the slides afterwards, so you can click through those and give this a try for yourself. So that will hopefully get rid of most of the paralysis and kind of unlock the NuGet community. And that, in a nutshell, is .NET Standard 2. This was the big thing that was released last year in this space. More APIs and the ability to effectively reference anything. I say anything with a star. It's not really anything. All that type forwarding magic ships for the .NET Framework and I think for some of the PCL profiles. Because the problem that was trying to be solved was that the gallery was full of packages for the framework, for the .NET Framework, and sometimes for PCLs, and we want to be able to use those in the new platforms. So it's effectively almost anything. Right, if I've got a package, what do I do if I want to port my package? What happens if I want to port my package from the .NET Framework to .NET Standard? This is a really, really good resource, right? .NET API port. It comes in two different flavors. It comes as a Visual Studio add-in, which I believe is actually packaged with the latest versions of Visual Studio. You can just right-click and say Analyze Project Portability, or you can run it via the command line. Analyze -f to a file, and it goes through, analyzes the entire assembly, and it spits out, of all things, an Excel report. But I think you can actually configure it to to output HTML and JSON as well. In that Excel report, you'll see something like this. So I ran it for NService Bus Core, and this is the current released version of NService Bus. NService Bus for .NET Standard and .NET Core is actually in beta right now. The current RTM of NService Bus targets .NET Framework 4.5.2. So unsurprisingly, the analyzer told us that .NET Framework 4.5.2 supports 100% of the APIs that NService Bus needs. For .NET Standard 1.6, the news isn't quite as good. .NET Standard 1.6 only supports 66% of the APIs that NService Bus needs. With .NET Standard 2, the situation is much better. It's 87%. And we decided that that's probably a reasonable gap to try and close. So we are aiming for .NET Standard 2 support in NService Bus. What do I do? What do I do to close that gap? What do I do to close that 13% gap, or whatever the percentage is in my library? There's a couple of things you can do. You can change your library. Now, there's two types of change you can make. You can make an internal change, where you're using something internally in your library to achieve something as part of your package. You can change that to perhaps some other API in .NET Standard, right? Sometimes that is an option. That's really nice because you don't have to change your public API. It's just a matter of just changing the APIs you use internally. Or you can make an external change. So you might be returning some object from your API which only exists in the .NET framework, or you might have a parameter on a method or something. You may have to change that. You may have to change that to some other object which happens to exist in the .NET Standard. That's obviously a breaking change. If you're following Semver, you're going to have to upgrade your major version, but that's just part of making that kind of change. You can separate. Now, this is a very, very powerful pattern. So in the example of NService Bus, NService Bus works over queuing systems. So you can use NService Bus with Rabbit, you can use it with MSMQ and Azure Service Bus and other things. The original version of NService Bus had MSMQ support built into the core DLL. So it was like the default queuing system. However, MSMQ doesn't exist on Linux or Mac, so it makes absolutely no sense whatsoever to have the MSMQ APIs as part of .NET Standard. Now, only a certain subsection of our customers use MSMQ, right? So we thought, well, why don't we just separate that into a separate package? Arguably should have been done to start with. But we just took that whole MSMQ slice out of the core package, put it into a separate one, and then made NService Bus Core depend on .NET Standard instead. Whereas the MSMQ package is .NET Framework. So that means if you want that, you have to stick to Windows. If you don't want that, you can use Linux or Mac or something else, and use one of the other libraries like the RabbitMQ integration, which supports .NET Standard. So that's a really powerful strategy for this. If you think there's a certain slice of your library which clearly depends on things which aren't cross-platform, slice it out, put it into another package, and that only makes sense if a certain subsection of your users need that. If all of your users need that, you're going to have to find some other solution. But if you know that only some people need that bit, put it into another package for those people, and those people can continue to rely on Windows and the .NET framework instead. And lastly, if all else fails, it might be a chance to kind of get rid of those obscure APIs that you think no one uses, or you know no one uses. It might just be time to chuck away something, perhaps. Again, that's going to be a breaking change, so a new major version. But hopefully you won't have to resort to that too much, and you can get by with kind of change and separate strategies first. APIs and versions of APIs of .NET. This is a really, really good resource. This is the most kind of complete resource out there for all the APIs that are available on every single platform in .NET, every single version of .NET Standard. You can go in there, you can search for anything like something like iData Reader. Okay, so search for that, and it'll actually tell you a little bit about it, methods and things. It's a bit like the usual standard docs, but then it will tell you every single platform it's available for. So it's available for all versions of .NET Core, all versions of .NET Framework. It's only available in .NET Standard 2. right? So this is one of the ones which was missing from .NET Standard 1.x. It's one of the ones that came back in, and various versions of Mono and so forth and so forth. So that is a really, really good resource. There is an element of works on my machine here. Who's heard of this kind of platform not supported exception? Yes, Liam. Oh, sorry. Yes, question. That was APIs of .NET. Yeah. Like I said, I will tweet the slides afterwards, and you should be able to get hold of them. So there is an element of works on my machine because there is this thing called platform not supported exception. Some of the platforms have effectively cheated in saying that they support the .NET Standard 2.0, and there is a very small set of APIs where at runtime you'll actually get a platform not supported exception. This is like the thorn in the side of .NET Standard, right? And I hope that this won't continue, and it is just a very, very small subsection of the APIs. Just something to bear in mind. You're very unlikely to hit them, but some platforms do this, right? So for instance, for process set this property on Linux, you'll get a platform not supported exception. And on OS X for this one here, you're going to get a platform not supported exception for other processes. So this is well documented. If you go to this API compat page, it actually lists all of these. So you can sort of take preventative action to make sure you're not going to get hit by this. .NET Standard versus .NET Core, right? So this is something I keep hearing confusion about. Now, I am hoping that through what I've already shown you in this talk, that the difference has started to become apparent. So .NET Core is just another one of the platforms. They do get conflated a lot in the literature and when people talk about these things, but effectively .NET Standard is that empty contract. Right? I showed you the base .NET Standard DLL, and it is empty. Right? You don't run in the context of Net Standard because the Net Standard DLL ultimately is empty. It is the platforms which provide the implementations. It is .NET Framework. It is UWP. It is .NET Core. .NET Core is another one of those platforms which happens to implement the .NET Standard. Question?
This one's caught me and my team out quite a lot because you can create libraries targeting .NET Core. There's .NET Core libraries. What's the point of those? Why do they exist?
Okay, so the question is, you can create .NET Core libraries. So why do they exist? Why do they exist alongside .NET Standard libraries? So a .NET Core library is the equivalent of a .NET Framework library for the .NET Core platform. So before all this started, right, back when it was simple single .NET, right, when it was just a .NET Framework, you created .NET Framework libraries to run on a .NET Framework platform, right? That was the old simple days. That's a platform, right? So that's an app, and it's a library which is designed for the runtime which that app targets. Over here, we've got .NET Core. We've got a .NET Core app and a .NET Core library, which is designed to run on the .NET Core platform only. It's completely analogous. .NET Framework here, .NET Core here. .NET Standard sits in the middle. Because .NET Standard says, well, I'm only calling APIs which exist in both. So the .NET Standard library is something you can take and run in the context of the .NET Framework app and in the context of the .NET Core library. Now, the reason for creating a .NET Core library might be because you simply can't achieve what you want to achieve using the .NET Standard APIs. That's getting much, much rarer now with .NET Standard 2 because it's so big. But it's still a valid use case. You might find that .NET Framework has the APIs you need. .NET Core has another set of APIs which you need, which do the same kind of thing. And there's just no crossover and overlap in .NET Standard. So you might choose to ship a .NET Framework assembly and a .NET Core assembly to support just those two platforms. Does that answer your question? Yeah. Cool. And yeah, these things do get conflated because this was, for instance, this was a snapshot. This page has moved on, but this was a snapshot of this page last year where .NET Standard 2 preview was scheduled for Q2, .NET Standard RTM was scheduled for Q3, and they hit these targets, by the way, right? Smack bang in the middle of Q2, smack bang in the middle of Q3, right? So kudos to the team. But when you actually looked at this page, it actually said this. It's like .NET Core and .NET Standard 2, .NET Core and .NET Standard 2. So watch out for that. So they're often mentioned at the same time in the literature. Sorry. And I think that does add to the confusion. But they are two separate things. .NET Standard could potentially exist if .NET Core stopped existing tomorrow. Right? It would still be useful, because you could produce a .NET Standard library and use it in .NET Framework and UWP or something, right? It is not in no way dependent on the existence of .NET Core. But in many ways, .NET Core drove the creation of .NET Standard, because it was the most popular alternative platform to the .NET Framework. So they kind of got developed in tandem, but they are completely independent things. I hope that's more or less clear. They're slipping a bit on the .NET Core 2.1 deliverables, but they did hit them for .NET Standard. This is another way of thinking about it. This is something that David Fowler put together. He created a repo where he actually defined an interface called .NET Standard 1.4, and then he kind of showed that .NET Standard 1.5 inherits from that, and .NET Core App inherits from that, and .NET Framework 4.61 inherits from .NET Framework 4.6 and inherits from .NET Standard 1.4 to show this kind of like interface versus implementation thing. I see a few furrowed brows, so I hope I haven't just undone all my good work by showing you that. But I think it does help to think about it in that way sometimes. So go and have a look at that. It may help to give another kind of perspective on how this stuff's put together. .NET Standard 2.1, 2.2, and 3. Now, what's going to happen? I haven't heard any whispers about .NET Standard 2.1 yet. Right? There doesn't seem to be anyone even talking about a .NET Standard 2.1. One of the concerns that people raise sometimes is that each version of .NET Standard is going to get bigger and bigger and bigger. So every time a new version comes out, it's going to put more burden on the platform providers to support a bigger API. And that is true, right? Because unless they make a breaking change and take something out, .NET Standard 2.1 by necessity has to be bigger than .NET Standard 2. However, .NET Standard 2 was such a massive change from .NET 1.6, it was such an increase that the idea was to include virtually all of the APIs that make sense on all the platforms. So while I think there may be a .NET Standard 2.1 at some point, or a 2.2, I'd be really surprised if there was a 3.0, because that would mean either they're making a breaking change, which I don't think they're going to do, or it means they've added a massive whole load of new APIs, and it's a massive kind of thing that I want to market and say, this is the latest and greatest. I mean, who knows? Marketing powers might sort of take over from that, and there may be a 3.0. But from the technical point of view, I would be surprised if there's a need for a 3.0. So how did I do? Before I wrap up, are there any more questions about anything I haven't covered yet? Who now thinks they've got a reasonable idea of what .NET Standard is? Right, that's almost all of you. Great. Who thinks they understand the difference between .NET Core and .NET Standard? Almost as many of you. That's really good. Excellent. Obviously, I didn't ask that question when I came in, so but I'll give myself the benefit of the doubt and say that I helped a bit with that understanding. Before I wrap up, any more questions? Yeah.
Is there any benefit for us to really understand those complicated diagrams you had when we're developing?
Is there any benefit to understanding the complicated diagrams? The answer may well be no, but they were quite interesting, weren't they? No? Maybe it was a bit of indulgence on my part. I don't know. I mean, maybe there is. I think it's interesting to know what's going on under the hood. Depends if your application runs or not. Yeah, I mean, ultimately, there are edge cases and everything, and if you know what's going on there under the hood, you might discover some kind of weird bug or something going wrong. So I think that there are uses, but I would say the majority of the time, I would hope there isn't much use, because everything should just be working as designed. Right, do need to wrap up. Maybe, so did you have one more question somewhere down here? Yeah?
Yeah, the sort of spreadsheet analysis thing. behind the scenes for N-Service Bus?
The spreadsheet analysis tool, how detailed is it? Is it something we're using for N-Service Bus? It is actually very detailed. I didn't show you the second sheet of the spreadsheet. It actually lists all the methods and properties that do exist and don't exist, the ones you're trying to use.
Write down the stack through your dependencies, not just your own code.
It won't go through your dependencies because that's the part of getting that dependency to work on .NET Standard. But it will analyze all the calls that your library is making, and it's a very detailed output. And yes, we did absolutely use it for N-Service Bus. All right, I'll try and wrap up now because the party is starting any minute now. If you're interested in knowing more about what we're doing with N-Service Bus in that context, and this will probably shed a bit more light on your question, go to these URLs. There's more information about what we're doing to support .NET Standard. This is just a little tweet which was put out. I think 2016 was rough. Martin's saying that here, but I was optimistic about 2017, and I think the team have really delivered in 2017. I think we're on 2.0, which is the first usable versions of .NET Core, .NET Standard, and I think 2018 is going to be really great. Let's get down to the party. Thank you very much.